So we're given f of x, and we're given a graph of f of x, and we're asked to find f of 2x, for example, a. How are we going to handle this? I would start by looking at these key points. So this is the point 0, 0. This is the point 2, negative 4. This is the point 4, negative 2. That's your basic reading coordinate grids. What you may not be as aware of is how we translate this into function stuff. So with 0, 0 being a point, that means f of 0 equals 0. With 2, 4, negative 4 being a point, that means f of 2 is negative 4. Like if x is 2, y is negative 4. For the point 4, negative 2, that means if x is 4, y is negative 2. So f of 4 is negative 2. That's just how the function itself is relating and how to write that in function notation. Now to use that to try and graph f of 2x, we basically want to make a table. And I'm going to recall these points backwards because it's easier to explain the purple point as opposed to the green point. So pardon me for that, and I'm going to write everything in blue right now. But I want to know what f of 2x is going to look like. I know that f of 4 equals negative 2. So basically what I got to figure out here is what x value, if I'm doing this transformation, what value for x will match up with f of 4? Or what x value could make this inside be 4? Or equal 4? And I hope you can realize that what I'm looking for is an x value of 2. If x is 2, then we have f of 4. X was 2. That gives us f of 4. And f of 4 we know from over here is negative 2. So that's going to be a point on our graph. It'll be slightly different. What about the fact that f of 2 equals negative 4? But I'm graphing f of 2x. So I need to know which x value will make this equal f of 2. And I hope you can see that if x is equal to 1, then we'll be looking at f of 2. If x is 1, then we have f of 2. F of 2 we know is negative 4, so that would be negative 4. And then finally, what x value would make this equal f of 0? Because I know about f of 0. And f of 0, we'll have f of 0 if x is 0. So it'll be the same point, 0, 0. So all of these points here are going to be the points that deal with that tell us about f of 2x. And I'll just kind of a quick shortcut. You may notice this. What's happening is, and it may seem slightly counterintuitive, but all these x values are half of what they were. Like what was a 4 is now a 2. What was a 2 is now a 1. Because we're going to double them once we put them in there. That's why we're going to use half. And the y values, of course, they haven't changed. Why would they? So if I plot these points, 2, negative 2 means I'm going to have an x value of 2 and a y value of negative 2. So that'll be the point that corresponds to the purple point. Then I'm going to have the point 1, negative 4. So if x is 1, y is negative 4. That's kind of how the blue point changed. And the green point didn't change at all. And then if you just connect these points together with straight line segments, you're going to be getting the transformation that we were after. So that's how that answer would look. Everything's kind of scrunched by a half. I hope that makes sense. Let me know if it doesn't. Send me an email. Or try the Alex examples and see if it makes sense. It's all about finding the x values that make the function match what you had in the first place.